All right, so for number 16, a particle moves along the x-axis with its position at time t, given by x of t is equal to t minus a times t minus b, where a and b are constants and a does not equal to b. For which of the following values of t is the particle at rest? So for this one, if the particle is at rest, that means that the velocity is equal to 0. Okay? So we need to find the derivative of the position function and then just set it equal to 0 and solve for t. Now you can find the derivative here either in two ways. You can use the product rule, right, because this is a product, or you can multiply it out, like, like FOIL, whatever, and then use the power rule. Did I say power rule before, or did I say product rule? Okay, sorry. Still have to sleep. Okay. So, is there any preference or not really? The product rule? Okay, yeah, let's do that. So when we use the product rule, this is one function and this is the other. So we're going to leave the first one alone, so t minus a, and then the derivative of the second. Remember that a and b are constants, so they're just numbers. So the derivative of t minus b would just be 1, because the derivative of t would be 1, and then the derivative of b is 0. That's okay? All right. So times 1, which I don't need to write. So then plus, now we find the derivative of the first function, so t minus a, which is again 1, and then leave the second alone, so t minus b, and make it equal to 0. Is that okay? Okay. So what we have here is, this is just t minus a plus t minus b is equal to 0. So this is 2t minus a plus b is equal to 0. So we're going to move everything over to the right side except for t. What was that? Oh my God, I don't know why I keep writing plus. Sorry, thank you. And my computer is spazzing out a little bit. Okay, minus. There. Okay, so we're going to add the a, add the b over to the other side. We get 2t is equal to a plus b, and then divide the 2. So that would be the correct answer for B. Questions on that one? Okay, let's go to number 17. Okay, the graph above shows the graph of f. If f of x is equal to the integral of 2 to the x, 2 to x, Jesus, of g of t dt, which of the following could be the graph of y equals g of x? Okay, so we would first need to figure out what is g of x. So if you use the second fundamental theorem, we would get that f prime of x is equal to, and then we take the x and we plug it in for t, so g of x, right? Because if I'm taking the derivative of both sides, yes or no? Okay. So f prime of x is equal to g of x, and they're asking which one of these is the correct graph. Now, if you look here, right, f prime, this is the graph of f, so f prime would be the slope of this line. The only thing that I really know about the slope of this line is that it's positive. So it's some positive number. Could be 1, could be 2, could be whatever, right? So the graph of g of x would be a horizontal line at the value of the slope. But it would have to be a positive number because, again, the slope is positive. So it can't be any of these, right? Because these are like parabolas, which when we take a derivative, the graph gets simpler, not more complex. So it can't be those. And this is similar to f, It's not a derivative. It's either a or b. It would have to be a because this is the one that has a positive number. And since this is a positive slope, positive number. Is that okay? Yeah. Okay. Nayarick, you okay? Because you had this face. I'm not sure. Yeah. Okay. All right. Number 18. So here we're trying to find the limit as h is approaching 0 of the ln of 4 plus h minus the ln of 4 over h. Now, we haven't seen this in a while, but do you remember what this limit is? It's the derivative, yes, but it's not necessarily of the ln of 4. What you have to do is identify what is the function and then what is the x value that they're asking for. So this is the definition of a derivative, which is, just as a reminder, it's the limit as h is approaching 0 of f of x plus h minus f of x all over h. So if you want to identify what the function is, we look here. They plugged in the x is equal to 4, right? Because that's the ln of 4. So the x value is 4. But the actual function is the ln of x. Is that okay? So if we want to find this limit is going to equal to f prime of x. So the derivative of the ln of x is 1 over x. And then what we do is that this is asking for f prime of 4, which is when we plug in the 4. So 1 over 4. I'm just going to let that sink in a moment before we go to the next. Questions on that one? Okay. All right, the function f is defined by f of x is equal to x over x plus 2. What points x, y on the graph of f have the property that the line tangent to f at x, y has a slope of 1/2? Okay, so slope of 1/2, that means that f prime of x is going to equal to 1/2. Yeah? So we need to find the derivative of f and then make it equal to 1/2 and then solve. Cool? Okay, so what this is, you have to use the quotient rule because we have x and then we have divided by x plus 2. So f prime of x is going to equal to, remember that quotient rule? I mean, this is how I remember low d high less high d low, all low squared. So low, right? So you bring up the bottom, x plus 2 times the derivative of the numerator, which is 1, less is minus. Now you leave x alone and find the derivative of the denominator, which is just 1. Yeah? All over x plus 2 squared. That's okay? Okay. And then the numerator can be simplified, right? Because we have x and then minus x. So we end up with a derivative of 2 over x plus 2 squared. So now that we have that derivative, we make that derivative equal to 1/2. Is that okay? The quickest way to solve this would be if you ever have a fraction equals to another fraction, cross multiply. Okay, so we have the x plus 2 squared times 1, that's just x plus 2 squared, is going to equal to 2 times 2, which is 4. So now what we're going to do is we're going to solve for x. So we can square root both sides. and we get x plus 2 is equal to plus or minus 2. Remember, anytime you square root a number, always plus or minus, okay? Unless it has something to do with like speed or time, but this is just a general equation, so you do the plus or minus. So that means we're going to get two x values. We're going to get, for x plus 2 is equal to positive 2, and x plus 2 is equal to negative 2. So we solve for x for each one, subtract the 2, we get x is equal to 0, and then here subtract the 2 as well, and we get x is equal to negative 4. So these are our two x values. Now they want points, they want the actual coordinate, right? They want the x and the y. But to save you on time, if you have your x values, just look at your options and see if just those x values are an option, right? Like we have here 0, 0 only, but it's 2 points, not 1. We have these fractions here again, it's 2, not 1. And we did get points, so it can't be that. It's either C or D. But if you look at the x values, both of these have 0, but then here you have negative 4 and positive 4. We got negative 4, so I don't even need to solve for the y because C is the only one that has the two correct x values. So that's just to save you on a little bit of time. Okay? Can I move on to the next? Okay. Let f of x equal to 2x plus 1 to the third, and let g be the inverse of f. Given that f of 0 is equal to 1, what is the value of g prime of 1? All right, so we're going to need to remember how to find the derivative of inverse functions. Okay, so the derivative of g prime of 1 is going to equal to 1 over f prime of 0. And I'll explain this now. All right, but g is the inverse of f. So that means that the x value of f is actually the y value of g, and then this is the x value of g. Because remember that the inverses, the y's and the x's, they switch places. Yeah? And so when you find the derivative, it's always 1 over the f prime of the y value of g. So the y value was given to be 0. Do you get what I mean? Okay. So we have to take the derivative of f. So f prime of x is going to equal to 3 times 2x plus 1 squared, right? Because this is the chain rule, times the derivative of the inside, which is 2, which is equal to 6 times 2x plus 1 squared. So now what we need is f prime of 0. So when we plug in the 0, we get 6 times 0 plus 1 would be 1 squared, which is just 6. So for g prime of 1, that's going to be 1 over 6. So D. Yeah, yes. hmm Is that okay? Moving on to 21. The line y is equal to 5 is a horizontal asymptote to the graph of which of the following functions? So remember the three rules when you're looking for a horizontal asymptote. One, if the degree of the numerator is smaller than the degree of the denominator, that means that you have a horizontal asymptote at y is equal to 0. If the degree of the numerator is larger than the degree of the denominator, then there's no horizontal asymptote. If you ever have a horizontal asymptote at any other number other than 0, that means that the degree of the numerator has to equal to the degree of the denominator. And then you would divide by those coefficients. Yeah? Okay. So it can't be A, because here in the numerator it's sine, and so like when you're trying to figure out the degree, it's not going to match, and we won't be able to find that horizontal asymptote. It can't be y is equal to 5x because that's a line, it doesn't have a horizontal asymptote. It can't be c because the degree of the numerator is 0 since there's no x, so this has a horizontal asymptote at y is equal to 0. For d, the degrees are equal. See how x and x. So we would divide 5, but this is -1. So 5 by -1 actually gives you a horizontal asymptote at -5. So it's not d. It has to be e. But see here the degrees. We have x squared and then we have x squared. 20 divided by 4 is 5. So e. Okay. Questions on that one before moving on? All right. Let f be defined by the function f of x is equal to the ln of x over x. What is the absolute maximum value of f? Okay, so in order to find the absolute maximum value, if it's asking for the value, this is the y, not the x. Okay, x's give location, right? If it says where is the absolute maximum, that would be the x value. But if it's asking for the maximum value, that's the y. So we need to start off by taking the derivative. We have to use the quotient rule here. We have no other choice. So this would be f prime of x is equal to, bring up the x, times the derivative of ln of x, which is 1 over x, minus the ln of x times the derivative of x, which is 1, all over x squared. So now here the x's will cancel, so we get 1 minus the ln of x over x squared. Is that okay? So this is going to equal, in order to find the maximum, it's going to equal to 0. To figure out when a rational function like this, when you end up with a fraction, when it equals to 0, you just have to focus on the numerator, when the numerator is equal to 0. Okay? So 1 minus the ln of x is equal to 0. So you can add the ln of x. 1 equals the ln of x. And then to cancel out the ln, we would apply e to both sides. Yeah? So e, and we get that x is equal to e. Now this is when the derivative is equal to 0. But remember that we're looking here for our critical numbers. Your critical numbers can occur when your function, when the derivative is either equal to 0 or when it's undefined. Even though there won't necessarily, like it's not differentiable at that point, it is still considered a critical number, and so you can still have a maximum or a minimum at that point. So we also want to make the denominator, x squared, equal to 0. So that means that the other critical number is 0. Is that clear? Okay. So now to figure out what is the maximum, we're going to create our number line. We have 0 and e. We look at our derivative, and we plug in numbers to the left and to the right, etc. So if I plug in -1, the problem with -1 is that ln is undefined at -1. Remember that ln only works from 0 onward. You can't plug in any negative numbers. So there's nothing going to be here. From 0 to e, e is 2 point something or other, so we can plug in 1. If you plug in 1, we get 1 minus the ln of 1 over 1, which the ln of 1 is 0. Remember, that's the only ln value that you need to remember. Okay? So 1 minus 0 over 1 is 1, which makes it positive. And then we plug in a number to the right of e, which would be, let's say, 3. If you plug in 3, you get 1 minus the ln of 3 over 9. Now, the ln of numbers, right, like 1 minus the ln of 3, I don't know what the ln of 3 is, but if you're going to be 1 minus something, like if you want to plug it into a calculator so you can see, the ln of 3 is some positive number. So it's going to make the numerator here negative. So this would be negative. Is that okay? Okay. So we have a maximum at x is equal to e. But remember that I need the y value. So you're going to go to your f of x and you're going to plug in e. And we get the ln of e over e. The ln of e, they cancel out. This is 1 over e. So it would be b. Yeah, you're always like, if you're trying to find critical numbers and stuff like that, especially for a rational function, critical numbers can occur when the derivative is 0 or undefined. So you just always set the numerator and the denominator equal to 0 to find those critical numbers. Because, like I said, even though it's undifferentiable and you know that, right, because the denominator is 0, that doesn't necessarily mean that you won't have a maximum or a minimum, or if it's increasing or decreasing, right? Because, like, let's say, for example, it could be something like this, right? Like your graph. This is a cusp, but notice that this is still a maximum. And I can still use this critical number to show that the left is increasing and the right is decreasing. So it's still an important number. Do you get what I mean? Okay. Next. If P of t is the size of a population at time t, which of the following differential equations describes linear growth in the size of the population? Okay, so here what we are given is the derivative of P. And it tells you that the population growth is linear. So that means that the derivative is the derivative of a linear function. Do you get what I mean? The only one here that would be the derivative of a linear function would be a. Because linear would be something like, in this case, they're using 200, so 200x plus 5, let's say. This is linear. You get me? So when you take the derivative, it would just be the 200. Yeah? Okay. Let g be the function given by g of x is equal to x squared times e raised to the kx, where k is a constant. For what value of k does g have a critical point at x is equal to 2/3? Okay, so what we have to do here is take the derivative, make it equal to 0, because that means that we have a critical number, and then plug in that x is equal to 2/3 and solve for k. So that's kind of like your strategy for this question. All right, so let's take the derivative. Here we have to use the product rule. So the derivative of the first is 2x, leave e to the kx by itself, plus now we leave x squared alone, and take the derivative of e raised to the kx, which the derivative will be, we copy it, right, e to the kx, and then times the derivative of the exponent, which is k. So I'm just going to put k here. Is that okay? And we make it equal to 0. And now we're going to plug in that x is equal to 2/3 because that's when we have a critical point. So g prime of 2/3 is going to equal to 2 times 2/3 what's it called, times e raised to the 2/3 k plus k times 2/3 squared times e raised to the 2/3 k equals 0. You got a hot mess here, but it's okay. So far, is this all right? Okay. So let's see what we can do here. Here we can multiply this. 2 times 2/3 is 4/3. E to the 2/3 k plus k times 4/9, right? Because we have to square the entire fraction. So we'll do 4/9k times e raised to the 2/3 k is equal to 0. Now, if we want to make this a little bit simpler, what we can do here is factor out the e raised to the 2/3 k. So that way, we can have like our factors and then just set the factor that has the k by itself equal to 0. You understand? So factor this out, e raised to the 2/3 k times 4/3 plus 4/9 k, and make this equal to 0. Now, e never equals to 0. Okay, so we can ignore this. This is what we're going to set equal to 0 and solve. So what we can do here is we can subtract the 4/3 over to the other side. So we get 4/9k is equal to negative 4/3. And then we multiply by the reciprocal. The 4's will cancel, and we're left with negative 9/3, which is equal to negative 3. So A. Any questions? Which of the following is the solution to the differential equation dy dx is equal to 2 sine x with the initial condition y of pi is equal to 1? So this is those separable differential equations. We can multiply the dx to both sides and then we would integrate. Okay, so dy is going to equal to 2 sine x dx. Now we integrate both sides and we get y is equal to negative 2 cosine x, since the integral of sine of x is negative cosine, and that constant just kind of hangs out, plus c. Is that okay so far? So we can already eliminate a and b because that's positive cosine. Now we need to plug in this initial condition. So y of pi is equal to 1. So negative 2 cosine pi plus c is equal to 1. You have to know your trig functions. What's the cosine of pi? Negative 1. Good. So negative 2 times negative 1 is positive 2 plus c is equal to 1. So subtract 2. We get that c is equal to negative 1. So our equation would be y equals negative 2 cosine x minus 1. So E. Are we good with this one? Okay. Let g be a function with first derivative given by g prime is equal to 0 to x, whatever that. Which of the following must be true on the interval 0 to 2? Okay, so let's see. From 0 to 2, well, I like to, if I see, notice that here it's telling me if it's increasing, decreasing, etc., right? So we kind of want to know what the function is doing from 0 to 2. So what I would do is I would plug in the 2. Because if I plug in 0, right, it would be the integral from 0 to 0, which is just 0. You get me? So we're going to plug in the 2 and see what we get and see if that tells us anything. So g prime of 2 is going to equal to the integral of 0 to 2 of e to the negative t squared dt. Okay, now I don't even need to evaluate this to know what's going to happen. The integral from 0 to 2 of e, even though e is an exponential function, right? So it's always going to either grow or decay, but it's never going to go below the x-axis because this is what it looks like. If it's a e is either like this or like this. Okay, this is if e is raised to a positive exponent, and this is if e is raised to a negative exponent. We have a negative exponent. It just means that it's decaying, it's a decrease, but it's still above the x-axis. So that means that this integral has to be positive. Does that make sense? Okay. So from 0 to 2, right, my integral will be positive. And look at the concavity. What's the concavity here? It's concave up, exactly. So if we're thinking about, oh, but sorry, I don't want to, we don't need, this is the first derivative, not the second, so ignore that. We can already eliminate C, D, and E because G prime of 2 is positive, so it has to be, um, what's it called, increasing, right? So to figure out the concavity, that means that we need G double prime of X, and then we'll plug in the 2. G double prime of X would be when we plug in the X, right? So e raised to the negative x squared. Is that okay? So then you plug in the 2 to see what's going on there, if it's positive or negative. We get e raised to the negative 2 squared, which is e to the negative 4, which this just means 1 over e to the 4th because of that negative exponent. But this, even though it's a fraction and it's going to be a very small number, it's still a positive number. You get me? So it has to be concave up. Okay. All right. Let's move on to 27. We're almost done with this part of the test. If x plus 2y times dy dx is equal to 2x minus y, what is the value of, now that notation, remember that this is the second derivative at the point 3, 0. So this is, what's it called, a implicit function. So we would have to take its derivative. You can, if you want, like solve for dy dx, but you don't have to. I mean, you can. Let me see something. What did I do? Yeah, okay. So what I did here on my paper was that I just worked with the function just like that and took its derivative or you can solve for dy dx and then use the quotient rule. I hate using the quotient rule, to be honest. I prefer using the product rule whenever I can. So I use the product rule here. Do you get what I mean? Because this is x plus 2y, and then here you have dy dx. So that's a product. Okay, so that's what, is that okay if we do that? Okay, so we leave the first alone, so it'll be x plus 2y. Take the derivative of dy dx, which is the second derivative, so d squared y dx squared, plus, now we take the derivative of the first function, which is 1 plus 2 dy dx. Leave the second alone. So it'll be dy dx. And that's going to equal to 2 minus dy dx. Does this derivative make sense? Okay. Now this looks a lot more complicated than you may think. Okay, this is what I did to kind of, because at the end of the day, I just want a number, right? I'm not trying to simplify this function or anything like that. So what I did now is that they want the second derivative at the point 3, 0. So what I did was I tried to figure out what is dy dx at that point so I can plug it in for dy dx everywhere that I see it. Do you get what I'm saying? So I took this, so the x plus 2y dy dx is equal to 2x minus y, and I divided the x plus 2y. So I get dy dx is equal to 2x minus y over x plus 2y. Is this okay so far? And then what I did was I took the point, that 3, 0, and I plugged it in. So dy dx at the point 3, 0 is going to equal to 2 times 3, which is 6, minus y, which is 0, over 3 plus 2 times 0, which is 0. So this is equal to 2. Is that okay so far? So then what I did, since this is dy dx at that point, I took this number and I plugged it in everywhere I saw a dy dx in this equation. So we have x plus 2y times d squared y over dx squared, that's the second derivative, plus 1 plus 2 times 2, because that's dy dx, times 2 is equal to 2 minus 2. Yeah? Then here I still am missing the x and the y, so I can plug in the x and the y that's given, and then solve for d squared y over dx squared. So 3 plus 2 times 0, which is just 3, right? D squared y over dx squared, plus, now this here, 1 plus 2 times 2, that's 5, and 5 times this 2 is 10. And that's going to equal to 0. So subtract the 10, we get 3d squared y over dx squared is equal to negative 10, and then divide the 3. So we get A. There's several ways you could have solved for this, right? Like if you didn't recognize to do this part here like I did here, you can also have solved for dy dx like I did there, use the product rule, right? And then plugged in the point everywhere you saw x and y. Questions? Okay. Okay, this is, I believe, the last question in this part, and then we have a few minutes left. We'll discuss it after. Okay. For t is greater than or equal to 0, the position of a particle moving along the x-axis is given by x of t is equal to sine t minus cosine t. What is the acceleration of the particle at the point where the velocity is first equal to 0? So we got to find a couple of things. We want to find the acceleration when the velocity is equal to 0. So I first have to take the derivative. So x prime of t, which is equal to v of t, is going to equal to cosine t plus sine t. Since this is, remember the derivative of cosine is negative sine, so minus sine. And then we make it equal to 0. Is that okay? All right. Now this is where it gets a little tricky. So we need to figure out the value of t. So what I could do here is I make cosine t equal to negative sine t. I just subtracted the sine over to the other side. So the angle of t needs to be an angle where cosine and sine are equal, right? Because if they're equal, then we're good. You know what I mean? Because if they're, does that make sense? Okay, so you have to think of what angle are cosine and sine the same value? Pi over 4, exactly. But we have, remember, right? We want either, so pi over 4 here or here. And why am I using these two? Because here cosine is negative and sine is positive. They need to be opposing signs because of one is positive and one is negative. Do you get what I mean by that? So this is the angle on this quadrant, it would be 3 pi over 4. And on this, in this quadrant, same thing. Here cosine is positive and sine is negative. So again, they need to be opposing signs. And this is the angle 7 pi over 4. But it says when the velocity is first equal to 0. So we're going to use this one, 3 pi over 4. Is that okay? So we take the second derivative now to get acceleration. So acceleration is going to equal to, I'm using this here, negative sine t plus cosine t. And now we plug in the 3 pi over 4. So we have to know our values here. For quadrant 2, sine of 3 pi over 4 is going to be positive, but we have, it's the negative on the outside, so this would be negative square root of 2 over 2 plus, and then here cosine in this quadrant is negative, so it'll be minus square root of 2 over 2. So here when I combine them, since I'm just basically adding them since they're both negative, this is negative 2 square root of 2 over 2, because there's two of those square roots. And so the 2's would cancel, and we get negative square root of 2. Okay? Um, what's it called? So we have about 10 minutes left. Do you want to start the calculator part and look at it? Yeah. What for? Okay, you need to be more specific. I don't know what you're talking about. Like what are you talking about exactly? Um, so the last two lessons is what you're referring to? So are you asking, because I'm trying to understand your question. Are you unsure of when to use the rotation equation versus the cross-section equations? Okay, so if you're doing, let me see if I can, I don't have any of that with me. Hold on, let me open up like an assignment just so that you can see what I'm talking about. Okay, where am I going? Okay, so do you remember if any of these gave you problems when you were working on them for the revolutions? If you're speaking, you're muted, so I don't know. Yeah, do you remember if there were any particular questions that gave you problems? Okay, let's see. Find the volume of a solid by revolving the following region about the y-axis, bounded by the graph f of x is equal to x squared, g of x is equal to 4, and the x-axis and the y-axis. Okay, so this is y. Here's the x-axis. Oh, I should probably draw. Okay, let me make this a little bigger. Okay, so this is the x-axis here. We are revolving around the y-axis, right? So, and it's this here. If you're ever trying to figure out what's outer and what's inner, because that's what you said is giving you a hard time, um, you always check going from the axis of rotation to the function that is mostly on the outside. Since I am revolving around the y-axis, I just basically, I hate this thing, draw from here to whatever I touch first. This is my function. There's nothing else outside of that. So this is my outer function and there's no inner function. Do you get me? Versus, let's see, number 3. Find the y star revolving on the following region about the line y is equal to 3, bounded by all of that. Okay, so this is the solid now, right? You're revolving around this line. So if I try to figure out what is outer and inner, from here to my first function, this is the inner function. And then from my axis of rotation, and I keep going, this is my outer function. Do you see what I mean? So you always start from the axis of rotation and like go perpendicular to the axis. You go to your function. You get me? Like this is my axis is horizontal, so you see my lines are vertical going to the functions to identify the inner and the outer. The inner is always like the smaller distance, the outer is the longer distance. Does that kind of make sense now a little bit? Okay. No, so what that's just letting you know the area. Because here it doesn't tell you, it only tells you bounded by this and this, so you can kind of identify like the actual solid, like where it is enclosed. So that y is equal to 4 is telling you the solid ends here. You don't keep going further than that. So when you're trying to write out your integral, right? This one would be, this is revolution, so pi, and this is revolving around a vertical line, so everything would be in terms of the y's. So that's why it's giving you y is equal to 4, because from the graph you can see it starts at 0 until the 4. So that's why that they give you that information. So it'd be 0 to 4, and then you would take your function, which is x squared, and then rewrite it for y. So y equals to x squared, square root both sides, and you get y is equal to plus or minus the square root of x. But this is the positive side, so I would use positive square root of x. Wait, sorry, it was, what did I do here? Square root of y. So stupid. There we go. dy. Okay, no problem. And then you said you had a question with the cross sections? They are. Okay, so here's the breakdown. The ones that you have to square are squares, triangles, and like isosceles triangles and equilateral triangles, those get squared, as well as circles. Those four. Anything else, if you have a rectangle, if you have a triangle that's different, like a scalene triangle, I doubt that you will get anything like that. But basically, rectangles are the ones that you don't square. The reason why that we're squaring squares, circles, isosceles, etc., is because the bases and the heights were the same. And essentially, what you're doing is you're integrating the area. You get me? So if you find area of a square, it's, let's say, x times x, so x squared. If you're getting the area of an isosceles triangle, base times height is squared. You get what I'm saying? Versus a rectangle where the bases and the height are not equal, what you do is you just find the area of that particular rectangle and then integrate. That's it. The squaring, that's because that's the area of that shape. If it makes it a little bit easier, then don't think about like the formula is to square. Think about just integrating the area. And you'll see that you'll be like, you can write your equation for the area of the square that's given and then just integrate it. I don't know if that kind of helps, or if you had like a particular question on any of these, I can go over that. Sure, let me find one. Here, this one, which is a rectangle, number 4. The base of a solid is bounded by the graphs of y equals x plus 1, y equals x squared minus 1. For the solid, each cross-section perpendicular to the x-axis are rectangles of height 5. What is the volume of the solid? Okay, so let's think about what this graph would look like. You have the line x plus 1, right? So x plus 1 would be like around here, right? Because it has the y-intercept of x, it has a positive slope. I mean, of 1 positive slope. X squared minus 1, that means it's a parabola that was shifted, let's draw this a little better, that was shifted down 1, so it would look something like this. Does that make sense so far? So this is where the rectangles are here. So first we would need to know these points of intersection. So I know how to bound my integral. So I would make x plus 1 equal to x squared minus 1 to solve for x. So I'm going to subtract everything over. I get x squared minus x minus 2 is equal to 0 because I just subtracted this over to this side. Yeah, we can factor. This is x minus 2, x plus 1 is equal to 0. So my points of intersection would be 2 and negative 1. That's okay? Okay. So now our volume is going to equal to the integral from negative 1 to 2, always smallest to largest. Now to figure out how to write out the area of this rectangle. It tells you that the height is 5. So remember, area of a rectangle is base times height. So I already have the 5, but I need the base. The base for all of your cross sections is always the high minus the low function. So this is the base. The high function, the one on top, this is the x plus 1, and the low one is x squared minus 1. So the base is going to equal to x plus 1 minus x squared minus 1. So if we put this together, we get x plus 1 minus x squared plus 1. So base is going to equal to negative x squared plus x plus 2. Do you see how I got the base? So the area of this rectangle would be the base, which is that, times the height, which is 5. This is area, so to find the volume, we just integrate the area. So the negative x squared plus x plus 2 times 5 dx. Okay, Matthew, no problem. Thank you. Okay. So the only time you really have to worry about not squaring is rectangles, if that kind of sums it up. Okay, guys, I do have to go. On Monday, we'll do the calculator part. Okay? All right, guys, I will see you. Have a great weekend. See you on Monday. Yes, I put them on Google Classroom. Yeah, I put because there was a lot of files for the actual like full length test, so I just separated. You have one with just the test and then another tab that says the answer keys. And you have the answer key for both multiple choice and the FRQs. What do you mean? Oh, I did back and front. Yeah, they should. Yeah, if it doesn't, let me know, but they should. That's how I did it. No problem. Okay. Bye, guys. Have a great weekend.